For our next series of questions, we're going to use SOHCAHTOA with right-angled triangles, but we're going to use it to help us determine the magnitudes of angles. Our first question reads, we have triangle DEF where angle E equals 90 degrees, so therefore we can use SOHCAHTOA. Side length E is 19 centimeters and side length F is 15 centimeters. We would like to determine the magnitude of angle D to the nearest tenth of a degree. So naturally our first move is to draw the triangle, sketch the triangle. And this is what we get. Angle E is 90 degrees. Side length E is 19 centimeters, which is obviously the hypotenuse, and side length F is 15 centimeters. So now we're looking for the magnitude of angle D. Well, we ask ourselves, with respect to angle D, what two sides do we know? Well, 19 is the hypotenuse. There's no changing that. So with respect to angle D, the side length of 15 is the adjacent side. So which trig ratio involves the adjacent side and the hypotenuse? We go back to our original sheet and we see that cos theta is the adjacent over the hypotenuse. So we're going to use cos theta here. So we write out our formula, cos theta equals adjacent over hypotenuse. Cos D equals 15 over 19, which is 0.7895. And we can therefore say, when we know that the cosine of an angle is equal to a specific value, we can find the magnitude of that angle by using the inverse trig function. So D is cos inverse 0.7895, and that is often the inverse trig button on a calculator is a secondary function. You'll see the second button up near the top, and then you can look for the inverse trig functions above the buttons of your calculator, so to speak. Well, we take the inverse cos of 0.7895 and we get 37.9 degrees. So therefore the magnitude of angle D is approximately 37.9 degrees. Okay, we'll try one more. We're given triangle MNP where angle N is 90 degrees, which therefore allows us to use SOHCAHTOA. M is 12 centimeters and P is 29 centimeters. We'd like to determine the magnitude of angle M to the nearest tenth of a degree. So we use our drawing abilities to put our triangle on paper, and we see that with respect to the angle M, we know the opposite side length as well as the adjacent side length. We actually don't know the hypotenuse in this case. Well, we go back to our original SOHCAHTOA formula sheet and ask ourselves, which formula is it that involves opposite and adjacent? And that's tan. Tan theta is opposite over adjacent. So we know that the tan of theta is opposite over adjacent. The tan of M will therefore be opposite is 12, adjacent is 29. So the tan of M will be 12 over 29, which is 0.4138. M is therefore tan inverse 0.4138, which is 22.5 degrees. So we can say that the magnitude of angle M is approximately 22.5 degrees.